Yes, children, regarding the theory of Wheatstone Bridge principle, the balancing condition and all that, yesterday we have studied, means in the uploaded video, it has been explained. Now, one numerical question based on that. The 4 arms, 4 resistance, 100 ohm, 10 ohm, 60 ohm and 5 ohm. A galvanometer is connected across BD and that galvanometer is having a resistance 15 ohm. The question, you have to calculate the current through the galvanometer, means Ig you have to calculate. So across AC, a battery of EMF 10 volt is connected, children. So let us come to the current distribution part. Only single cell is there. So let us consider the current I is leaving the positive terminal of the cell, and it should end or it should get into the negative terminal also. So leaving current I, the ending current I. And here at this junction A, the current, 2 branches are there. So out of the total current I, one part I1 is flowing through this 100 ohm, other part I2 is flowing through this 60 ohm. Now at the junction B, current I1 is coming to the junction B, and out of I1, one part Ig is flowing through this branch. The rest current I1 minus Ig, applying Kirchhoff's current law. I1 minus Ig is flowing through this 10 ohm coming to the junction C. Junction D, I2 is coming to the junction D, Ig is coming to the junction D. So the current leaving the junction, the current through this 5 ohm, that will be I2 plus Ig. Okay. And at the junction C again, I1 minus Ig is coming here. I2 plus Ig is coming to the junction C. Therefore, the total current leaving the junction C will be I1 minus Ig plus I2 plus Ig. You will get it as I1 plus I2. And that I1 plus I2 is equal to I. So, we have done the current distribution. Everything is okay. Now, to calculate Ig, we have to form the equation. We have to consider the different loops. So, first you consider this ABDA. ABDA. We have 3 resistors and EMF battery is not there, so we will equate to 0. And when we consider ABDA, this is the direction of traversal. Through 100 ohm, current I1 is flowing in the same direction. So 100 into I1 is positive. Then the direction of traversal of through the galvanometer is also, and the current also in the same direction. So PD across this galvanometer is also positive. So plus 15 Ig. Now this direction of traversal is in this way through this resistor 16 ohm. But current, see the direction, I2 is coming in the opposite direction. So both are coming negative. So potential difference across I2 is negative. So I have written minus 60 into I2, which is equal to 0 because in this branch no battery is connected. So we got one equation. Now considering we have 3 unknowns. I1 is there, I2 is there, Ig is there. So minimum 3 equations we need. So consider one more loop, say BCDB, BCDB. So BC, in this way it is getting traversed. Direction of current I1 minus Ig, direction of traversal, both are in the same direction. So it is positive. So 10 into I1 minus Ig, that is positive. Then this is the direction of traversal. Current I2 plus Ig in the opposite direction. So PD across this 5 ohm will be negative. So I have written minus 5 ohm. 5 into current is I2 plus Ig, minus sign. Then BCDB, this is the direction of traversal through the galvanometer, but current through the galvanometer, both are in the opposite direction. So again minus 15 into Ig. Okay, and again there is no EMF, so equal to 0. Second equation we got. Now at least one equation with the cell EMF we have to consider, then only we will be able to solve that. So one more loop, A, D, C, E, A. Including the cell, one loop we have considered. So AD, this is the direction of traversal. I2 is also in the same direction. So 60 I2, positive 60 I2. Then this is the direction of traversal, direction of current I2 plus Ig through 5 ohm, both are in the same direction. So plus 5 I2 plus Ig. So only 2 resistors are there. Then one cell is there. So ADCE. Which terminal is coming first? Negative is coming first. So lower potential to higher potential, we have discussed, is already positive. So equal to plus 10. So you got 3 equations. You can solve it. You can get the value of I1, I2 and Ig. And when you calculate, you will get it as 4.87 milliampere current through the galvanometer. Okay. So do the calculation and get the answer.